Chapter 21, the non-inverting amplifier configuration. In this we select and open Chapter 21, circuit, non-inverting amplifier configuration. Now I have new blank. Now we will open a blank schematic. Add the op-amp in that. Like page 1 as the VCCS is voltage. Now in this circuit we need an op-amp. It will be of US741. Select the US741 as an analog parameter. Now two RF resistance, RF1 and RF2. This is feedback resistance. This is non-inverting configuration. This is called voltage, common voltage source. It is called volt to volt transistor. There is a linear correspondence between the input voltage and output voltage. Now add this V1 and V2 are plus 5 volts. This one is the input signal. Add the groundings to the input sources and the source to the IC. Connect all the circuits. This one is the R load. The negative connected to the 10% of the output is negative feeded back to the input. Now this one is the source connected to positive terminal. Connect the ground to the 15 volt DC supply to the IC. That's a VCC. That's a VEE. The VCC and VEE is a plus 5 volts, plus 15 volt and a minus 15 volt. 15 volt DC will be given to the IC, VCC and VEE. This is 15 volt DC, VCC and VEE. This one is the load resistance. Change the number of resistance. RVL with a different value of the load resistance we're gonna give it to. This will be like varying load or parametric sweep. Configuring the input signal as an 1 volt amplitude, 1K frequency, 1 volt. RVL equals to 1K. Select as 1K RVL. So this is the parameter which gonna be the changing. That's the VSCS. Now select the runtime from 2 milliseconds. Parametric sweep we are giving for the RVL. Now give the V output voltage. This will be our net alias, where we gonna check the output is V input. Run the simulation. So we're giving parametric sweep. Now generate an output graph. That's V output voltage. RL is 5K. Now generate the R graph for the this is the noise graph, value of the noise. Now change the value of RF1 as 1K. We can analyze the signal to noise ratio effect on a negative feedbacks. So we have RF1 is equal to 9K. RF1 have a value of 1K. We're gonna give a DC sweep for this one. $1K and $9K will be different value of the RF1 we're gonna go through. This will be different value of RF1. We're gonna generate a parametric sweep for that one. These are all the different values of V output or V input for different value of RF1. This is the analysis of the signal to noise ratio for the different value of RF1. If we increase in the signal to noise value of the feedback resistance, there is all changes of the SNN. For all the curves, the ideal formula of midband approximately holds, and also the new values are 378.8, 196. Now make another lab for VCIC, another schematic VCIC, VCIS, I'm sorry, voltage controlled current source. So there will be control source and there will be voltage controlling via a current source. This is all the current both the VCIs has configuration. Now it's also same LVCC, just only the difference in this is that we have got our inverting these are all the input values we're getting. So we have to make all VCIs as far, so in order to make an output which will completely depend on the current, so in the input we give the voltage. Give the 15 volt DC supply to the IC. 1 volt 1k1 to the input of positive amplifier. This one is the VCIs configuration for the non-inverting input. Generated profile for chapter 21 VCIs. Give the 2 milliseconds to 20 milliseconds. Generate a parametric sweep RVL. One K 9K99. For RVL we have value of 1k. This one is the value of I load. VCO versus the V input for various value of RL. Change the simulator parameter. This is sweep. Now this will be a primary sweep of voltage. This one is a transfer function graph of I output versus the V input for various values. Now we're gonna have a DC sweep and parametric sweep. That's all we got it. Now divide this one by V input. This will give the transfer function. That's our transfer function curve. Transconductance, it's called transconductance curve. And give the 1 volt AC supply. This is the graph of dB, V output by V input.